All right. So currently we have 3 buttons. Page 2 goes to screen 2. And are we printing something out? Yeah, we're printing out a name that was probably stored in. All right, so right now we have, so remind me, in what's this view? On next page button pressed, what does this view mean? We talked about this last class, so we'll see who actually watched the video from those of you who skipped. Yeah, the dude who pressed the button gets passed in. All right, good. So you watched the video, right? Did you do the homework?
Well, I would if I had a place to put it.
Well, you should have done it and then found that, oh, I don't have a place to put it. And then said, oh, Professor, I'm just dying to submit my homework assignment. Well, you're going to wish you did when you see your assignment over the weekend.
Are you going to open that for that? Open exam for this? Well, it's really simple homework. Like, what are you're asking to just use the 2 methods that you were talking in class. One is use put extra and one is a simple one, right?
Okay.
Yeah. You want us to make, I think it was 2 or 3 pages and use either one. Yeah.
Oh, show both.
Yeah. I watched the video.
Weren't I already doing it? So if we go to page 2, I'm creating a link that goes to screen 2. I'm saying I'm putting an extra there. We were checking last time to see if put extras, we serialized a value, right? We looked at interfaces. That would be a good quiz question, wouldn't it? Interfaces? Remind me, what's an interface? So who? Okay, that's not necessarily wrong. What were you going to say?
It's the physical visual thing.
Physical visual thing.
Anything in the user interface. Oh, yeah.
It's what you build.
Did you watch the video? You didn't watch the
Last
video.
night.
So no.
Not recently.
You watched it last night, but not recently? Were you like watching Netflix at the same time? Or were you sleeping at the same time?
I watched Netflix after.
So what we looked at interfaces last time. Specifically, we looked at the serializable interface. I think I also mentioned another interface called runnable to kind of tell you how interfaces work. What's the point of an interface? Why do they exist? You know it already because I heard what you said. So somebody else. I don't think you gave away the answer yet, but what you said is a very accurate answer, but it's a little bit of a coded answer, kind of like parenthetical notation. So what are interfaces for? What do they force us to do? Maybe I've already said too much. You got an answer? Okay, tell me your idea. That's okay. Ideas are fine.
They force us to they narrow down the options into a concise sort of display for us to use.
Display for us to use. Yeah, so an interface doesn't really have anything to do with displaying things.
Similar to a class, but the people who wrote it, you have to use what they gave us.
Okay, so these things are like classes, but they don't give us an implementation, right? Instead, they say, here's a set of functions that you must implement in order to adhere to this. I think I gave an example last time when you have, I think I said something with the Xbox, right? Like if you have an Xbox and, Microsoft makes controllers for the Xbox, but then you might have a third-party companies that also make controllers for the Xbox. Well, so the Xbox has an interface associated with it that says, if you want to make a controller that talks to the Xbox, you must write these 4 functions or something like that. Those are the 4 things we expect you to have because we're going to call those when we connect to your controller. So any third-party company who wants to write an Xbox, who has to create an Xbox controller has to implement those 4 functions in order for their controller to accurately speak to the Xbox. That makes sense? So Microsoft doesn't say what those functions need to do on their end. So, company A can do all sorts of fancy stuff in there to make their controller better than somebody else's controller. But at the end of the day, that function needs to take a certain kind of parameter and spit out a certain kind of answer. Make sense? To make it compatible with that. So that's what interfaces are. Serializable, the reason I mentioned runnable last time is that serializable, which we had to do for packaging an object with extras. And what are extras? How do we use extras? When I say put extras, what's that guy associated with and what's its purpose? Go ahead.
Moving data from one activity to another.
Okay. And who is it associated with? Currently on my screen.
Oh, I see. It's associated with intent.
The intent. Okay, so we have this object called intent, which is kind of our mechanism for saying we intend to do something. Right now, our only intents are going to other screens. But that intent comes with a suitcase called extras, and we can throw stuff into that suitcase so that travels between the 2 activities so that on the other end, we can grab the intent that was associated with this activity and pull things out of it. So something we ran into last time was we saw that put extras already has kind of the pre-built ability to deal with all of our primitive types, knows how to deal with strings, and it also seems to has built-in stuff for dealing with most arrays of primitive types. But what it didn't know how to do was deal with objects, specifically deal with objects. So what we had to do is it had a version that knew how to deal with something that was serializable. Right? So what we had to do is we had to go into one of our objects, and this was my object. So my object, notice that we said my object does something called implements serializable. That gets us from so it says that this guy is one of these guys. Now the reality is that we didn't actually have to write any special functions to make serializable work. So serializable did not require us to actually write something as from our end. It just required us to mark our object as being of type serializable to say that we've thought about this. It's kind of dumb why they would do this, but my guess is that there is additional overhead that goes along with an object being a serializable object. And because of that, you wouldn't necessarily want every object to be serializable. There's probably a cost to being serializable. But what serializable does is built into Java, there's a mechanism for taking an object that looks like this and describing it in such a way that it can be sent between 2 things inside the intent so that it can be kind of put back together on the other end. So think about it like the transporter in Star Trek, right? Where things dematerialize on this side and show up on this side. So we serialize them over here. And when we think about communication in computer science or in networking, serial communication is 1 bit after another, as opposed to parallel communication, which is typically in 8-bit chunks, but doesn't have to be 8 bits. It's just more than 1 bit is parallel. So we serialize the data. It streams between our 2 things. And on the other end, does anybody remember the term I mentioned for how you put it back together? Marshalling. Yeah, marshalling is the term. You will very rarely, if ever, hear that term again. But it is the official term that's under the hood. So I don't remember where I learned it, but at some point I heard that or I had to deal with it. I think I had to, this was in an earlier language, I had to write a marshalling, and instead of serializable, it was called unmarshalling, to get things into a certain format, and that's the term for it. I won't ask that like on a test or something like that, the marshalling question, but maybe store it somewhere as it's not a high importance type thing, it's more of a trivia question thing.
It says it's converted into a byte stream. What is that?
Serializable? Yeah, serializable. like I mentioned a few minutes ago, think about like the transporter. So when we say something is communicated in serial, in networking, when it's one bit after another or one chunk after another. So if it's saying byte stream, that means it's sending a byte, which is an 8-bit value, which is the smallest value that Java can represent, right? So it's effectively Java's version of a bit is a byte. So it's one byte followed by another byte, followed by another byte, followed by another byte. So in a stream. So it's sending that from this place to this place. Make sense? Yeah, so they're just having us mark this object as serializable, and then Java does the rest of the magic. So last time I mentioned another interface that exists that's kind of a popular interface called Runnable. And Runnable works in conjunction with threads. If we want to write a multi-threaded application, which we will do in 300, it requires you to implement a public void run method that the thread start function calls. And whatever you have inside of run is like that's like your main method for that thread. Okay. So let's see what we're doing here at the current thing. So when I go to page 2, I'm creating an intent. I'm putting an extra called Dave. This guy is called, putting an extra, this is a string. So variable my name associated with the string Dave, starting that activity. And this is screen 2. If I go to screen 2, what am I doing with that? I'm printing out, I'm grabbing that variable from the get extras called my name, and I'm printing it out. So that'll get Dave over there to screen 2. If the button I pressed was page 3 button, I'm going to create an intent to go to screen 3. I'm actually doing nothing with it, and I'm just starting the activity for screen 3. And what does screen 3 do? Screen 3 goes ahead and it grabs core.myname. So core is my singleton, this guy right here. And my name is going to be NA initially. So that's what that button will do. Just print out NA because we had no way of setting it before that, unless we did something else on the screen that set it. And then, oh, so did I say you had to write like a text box, like an edit text to type something in and have that set the singleton to send it between 2 screens? Was that what the homework was supposed to be?
So I think it was just send it one way to one screen, send it another way to another screen, and I don't even think we had to send it via text box.
Did we already do that?
No, we just did the text box.
No. Didn't we already send things through? I mean, we just showed you sending the intent between 2 screens. Right. Now I'm going to show sending we go back here. What do we do in button 4? This is where we sent our object. So was it sending, because we were checking, your question was last time whether or not the object was passed by address or passed by value. We saw it was passed by value. So we couldn't make a change. So was it to pass that object through the singleton? So we could make a change to it? Was that the punchline? Because when we came back here, this on restart, what's this guy? When does this guy get called? So when an activity restarts, this is part of the activity lifecycle. So prior to this, the only part of the lifecycle we worked with is on create. So on create happens one time when a activity is first created. On restart gets called every single time we come back to an activity. All right, so that's when that guy gets called. So what were we doing on here? We were trying to print out the object's name. So what we might want to do is to prove, so here our page 4 button, we created our object called this object, which we did up here. So here's this object, we set it to Mike. We passed it into page 4, which calls screen 4 class, but we did it as an extra, okay? Because that guy was serializable, so that was compatible with our extras. So we went to screen 4. Screen 4 went ahead and grabbed that object, by getting the serializable object from our baggage, our extras. Then we printed out the memory address of that guy to kind of prove to ourselves that it was actually a different memory address. So this was not being passed by address. This was being passed by value. Then we tried to set the name of it from Mike to Dave. Printed it out here, proving that it was Dave. Then when we go back to our main screen and we get inside of on restart, we printed out the name of the object again and it reverted back to Mike. All right, so this was all related to that button 4. And we were hoping, well, if we were trying to change that value permanently, so if I go to page 4, there's the Dave. So it received, let's see, did it show Mike the first time? So here, I never actually showed it the first time, but it originally was Mike. We're on screen 4 here. As part of this, after I showed, after I read it in as Mike, changed it to Dave, then printed it out. So I proved that it's Dave now, that my change happened here. Now when I hit back and we restart the previous activity, I'm printing it out again. And we wanted to see, does it show me the changed variable, which it would have only done if we had passed it by address, or does it show me the original, which is what it does show us because we passed by value. So what we just changed here on this screen to Dave was a brand new object that has nothing to do with our original one. So there's Mike, that's the original. Okay? And if you think about that in Star Trek terms, that's a little scary. So that means every single time they beamed down to the surface of a planet, there was a copy of the person that got beamed down. Right? What happened to the original Spock? How many Spocks are we dealing with here? Just gone. Garbage collected. Java Virtual Machine's garbage collection. So what we want to do here is we want to give ourselves the ability to have an object shared between 2 screens and be able to change that object. All right? So we can't do that through extras. Instead, we're going to have to do that through a singleton, because a singleton will allow us to pass that by address. So let's go ahead and do that with our button 3 here, this guy, since we're not currently doing anything special in this guy. And what does screen 3 try to do? Yeah, he's printing out something from core. So we'll use our screen 3 button, or we'll use that button and do it with screen 3. So we'll go into core, and we're going to create a variable, public static my object. We'll call this my obj. And we'll start this guy off at null, even though that is the default value for it. I'm going to specify that it's going to be null. Okay, so now I have a global. Now, what kind of animal is this? It's a field. Okay, it is a field. What kind of field? Instance field or class field? I heard class and I heard instance. Who's right? Class. Why is it a class field? Because of the static. So this guy is a field. That's the variable associated with an object because no parenthetical notation. Okay. What are the options? What are the 3 different kinds of things that can live inside of a class? Method. Constructors, fields, and methods. All right. So this guy is a field. Fields are our variables. Constructors must match the name of the class and have no return value. Functions have a return value, don't have to match the name of the class, and just like constructors will have parenthetical notation. Okay, so this guy's a field. Specifically, he is a class field because we've defined him with the word static. How do we access class fields? How do we use class fields? Using the name of the class in which the field was defined, which is inside of core. So we say core dot my object. All right, to get to that guy. That's how our singleton is working. So over here in main activity, remember that when we first created our main activity, we have our myObject obj, and we set that guy to be a myObject with Mike as the string. So before we go to page 3, we're going to go ahead and say core dot myObject is equal to this dot obj. So we'll go ahead and attach that object to our singleton. Then we'll start our screen 3. Screen 3 will catch this guy. And we'll go ahead and print him out. We'll say core dot myObject dot get name. So that'll print out the name. So that should be Mike the first time. Then we'll say core dot myObject dot set name to Dave. Then we'll print it again, proving that the change has happened. Then when we hit the back arrow and we come back to our main activity, on restart, we're going to print out object.getName. Should be Dave now. Now, why didn't I say core.myObject.getName? Who owns obj? This guy does. All right, so this guy must be an instance field inside of this class. How do I know it's an instance field? Because I'm calling it using an instance of this class called this. So if I scroll up, I should see somewhere at the top a variable named obj that does not have static in front. Scroll up, obj, no static. Now, if over here in screen 3, I changed core.myObject, and that was the guy who I changed here, and I came back to main activity, on restart, I'm printing out this .obj.getName, not core.myObject. Is this wrong? Trying to print out Dave. I changed core.myObject, correct? So I go in here. I'm going to page 3, right? When I go to page 3, the very first thing it does is it prints out core.myObject.getName, which should be Mike. Then it's going to change it to Dave, then print it out again, so it should say Dave. So there's the Mike and there's the Dave. Now when I hit back, I'm printing out this .obj.getName, which should be what? Mike? Of course it's Dave. Are they? Let's go to our screen 3 button here in main activity. Core myObj is equal to what? They're both pointers to the same variable. So core.myObj, draw a picture here. All right, so this is main activity. Down here, main activity has a local variable called obj. Okay? It's a local variable called obj. Then we have core up here. And core has a local variable called my obj. Okay, so these are our variables. Now, here in main activity, at the very top, I set this.obj equals to a brand new my object passing at Mike. What does the new keyword do? It's this memory, right? This new keywords, our real estate agent goes and grabs us some brand new memory and then uses this constructor to build. It's this constructor with these building materials to build a my object for us. So what happens in here? Well, we get this guy will be yellow. So this is this object call that with Mike in it. Okay, and this guy lives at some memory address. So like, you know, it's 0xff2a or something like that. Memory address, right? And this is the new memory that was created that we constructed the object on and we associated with obj. So that means obj points to this guy. Correct? All right, so obj points to that guy. Now, in page 3 button, what do? I say core.myObject is equal to this.obj. The value of this.obj is the memory address of my object. So what does that line do? It does this. So core.myObject points to the same place in memory that. No, this guy equals the value that's stored in this guy. And this guy holds a memory address, which is a pointer. So now this guy holds, so really if you want to look at what it actually looks like, the value inside of my object is going to be 0xff2a because the value inside of obj was 0xff2a. Those are memory addresses. So because its value is a memory address, it points to the same thing here. So core.myObject equals the same value that this.obj equaled. So they both have the same value inside of them. And since that value is a pointer, it's a memory address, they both point to the same place, the same destination in memory. Make sense? So now when I come into screen 3 and I change core's my object set name to Dave, what is that doing? That's going to core's my object, which goes here, and I'm setting that name to Dave. Then when I hit back, I'm back here on main activity. I go to on restart. I'm printing out this.obj get name. Here's this.obj, which goes to that same place in memory, and the guy's name is Dave. Make sense? So this is how pointers work. Really, really important concept. This would definitely be something I'm going to be testing you over. No marshalling, but this. Maybe you'd prefer the marshalling one. And this is historically something that's difficult for beginning programmers to kind of grasp because memory is a very intimidating thing, right? Just because of the weird, it's just not, it's weird, looks weird to us. But when you draw a picture this way, it was pretty easy once you actually looked at it, right? Okay, anything that looks like a memory address is said to be a pointer. Pointers point to places. Okay, we have one place and two different things that point there. Make sense? Okay. So that's what's happening there. Now we're proving that we can permanently change an object if we do it through a singleton rather than through a serialized object passing it through put obj. Now, an interesting thing to then explore is then we ask the question, are all variables that are passed through extras passed by value? We definitely saw that serializable objects are definitely passed by value, right? Under the hood, a brand new version of Spock was created, right? And that's who was actually delivered to our second screen. So any changes we made to that, we were making to the clone. The original did not have an impact. But if you remember in put extras, so let's look here on our, why don't we work with page 2 here for this one. All right, so we look at put extra. Notice we have a whole bunch of different kinds that we can put in here. And let's just work with something that we've used a lot. So here's an integer array. Okay? Integer arrays, historically, we've seen are passed by address, right? These guys are memory locations. So why don't we go ahead and create a local integer array. We'll print out its address. Then we'll pass it to the other thing and print out the address again. Let's see if it makes a clone of that integer array or if it passes the integer array by address. So we'll go ahead and we'll make a private int array, call it AR. And I want this integer array to be an integer array with capable of holding 10 elements. So how do I make, if I want to write the line of code here to make AR be an integer array capable of holding 10 objects, what line of code would I write? This was something from our midterm that was missed way more than it should have been. So right now AR is a variable. And what's the value of this variable? Nothing right now. I haven't given it a value. It's null. So now I want to actually give it a value. I want AR to point to an integer array with 10 buckets in it. How do I make that happen? Right here. Go ahead.
AR equals new
Okay. Like that. So, and this is not new A. It's not AR. It's new int array. That guy. But I think you would have. You knew it. You got stuck on the AR thing. All right. So this creates a new integer array. So this creates new memory, right? And it's going to create a new integer array capable of holding 10 things. Now I want to fill it up with 10 random numbers. Actually, let's just fill it up with the numbers between 1 and 10. Keep it simple. So how would I fill this guy up with the numbers 1 and 10? Somebody else. For loop, okay. So for int I, where do you want I to start? Okay, we'll do 1 and 10. I want to go filled up with 1 to 10. Okay. Start at 1. Keep going as less than or equal to 10. And then I plus plus. For int I is equal to 1. Now, we could have started at 0, just filled it up with 0 or whatever, or we could have added 1 to I each time. It didn't really matter. So we'll say this.ar at bucket I is, oh, actually your 0 is going to be smarter. Because now, since I'm accessing bucket I of this, I'm going to have to say I minus 1 is equal to I. That is bucket 0 is equal to 1. Where he wanted to say 0 to this.ar.length. So then we can say I is equal to I plus 1. So his answer was actually the better answer, or probably the better answer. Looks a little friendlier. So bucket 0 will be a 1, bucket 2, or bucket 1 will be a 2, bucket 2 will be a 3, so on and so forth. Bucket 9 will be a 10. All right, so now it's filled up with stuff. And then let's quickly create a print array function. So we'll create a private void print array. Now this guy doesn't have to take any parameters because it's a global variable in here, right? We already know about our array. So we'll say for int I is equal to 0, I is less than this.ar.length, I plus plus. What kind of animal must length be of AR? Field. No parenthetical notation. All right, so that guy's a field. Class field or instance field? Probably an instance field because this guy doesn't appear to be the class name because it's not capitalized. And in fact, we actually know it's an instance because we wrote it. So we'll go ahead and do a system.out.println this.ar at bucket I. That should print out each element on a different line for that. So we'll go ahead and initially, when we first create this guy, say this.printArray, printing out our 1 through 10, showing that that's working. Now, on our page 2 here, we want to go ahead and package that array up and send it to our second page. So we'll go ahead and say I.putExtra, and the extra we're going to put in here, we're going to call it myAR. You can name it whatever you want, but we'll just call it myAR, and we're going to put this.AR in there to pass that array. Now, one thing I'm going to do right off the bat before we actually call this activity is I'm going to say system.out.println AR. I like to saying this.AR, but same thing. What should that print? Memory address. Okay, that should print the memory address of AR. Then on our screen 2, I'm going to grab my AR and I'm going to try to print his memory address. Let's see if they look different. So that's screen 2. So I'm not going to get the name anymore. I'm going to say int array AR is equal to this.getIntent.get int array extra. And this guy was called myAR. That's what I named him. And then let's just go ahead and print out AR. And let's see if they're the same memory address or a different memory address. Does it create a clone of our array, or does it pass our array by address? I'm guessing. Go ahead. Here? It does need to be because I believe over in main activity, that's how I named it. Yep. So however you name it there, call it the same thing on the other side. Okay? You could call this elephant. You know, it could be any variable name you want. Now, my guess is this guy is going to be a different memory address because that's how objects behaved. And since objects behave that way, it would be surprising if this guy behaved differently. Now, at the same time, though, the reason why it might give us the same memory address is that objects were kind of a special case. We had to do that serializable thing, and there might be more than meets the eye under the hood for that dude, which means that maybe the things that are built in are actually passed by address instead of passed by value. And we'll know right off the bat. Let's go ahead and run this, and we'll hit our first button. Let's try that again. No. On create, it hates this slide. So here's my new array, int array, size 10. Start I off at 0, keep going as long, less than or equal to. See, I should have just taken his advice to begin with. I've written a nice for loop that's the same for loop we've written 100 times instead of writing this newfangled thing, right, to try to be clever. So, finally, I introduced my first bug. Shameful. All right, so now this guy should cook. And we should have our 1 through 10 printed out here. There's our 1 through 10. We'll go in here, we'll go to page 2, and when I go to page 2, it's going to print out the memory address of this.ar. Then it's going to arrive at page 2, it's going to get my AR and print out the memory address of that dude. And I suspect they're going to be different memory addresses. And they are. So passing them by value, which means any change I make to those guys is going to be a temporary change. So if I go into screen 2 and I say AR at bucket 0 is equal to a 35. Okay? If I print out AR at bucket 0 here, it will definitely be a 35. Okay? So I won't even bother printing it out. We'll come back here to main activity, and on restart, I'll go ahead and print my array again. And we should see it's still filled up with 1 through 10. Because what I changed is the array at a different memory location. All right, so it should be changed now to 35. I go back, and there's my 1 through 10. Make sense? So if I want that guy to change, I'm going to have to use my singleton to get a permanent shift between those things. All right, questions about kind of active examples of pass by address versus pass by value? Go ahead.
So why wouldn't you want to always use a singleton then? Wouldn't you want like changes to be saved?
Well, maybe. Or maybe you don't intend on changing it. So for instance, let's say you pass the username from screen 1 to screen 2. You're probably not going to change their username. The username is whatever it was logged in as. So, I mean, you're right. You would always use a singleton if you passed an object that you intended to make changes on to different screens in your application, and you wanted those changes to be felt throughout the rest of your app. You would use the singleton. But if you just need to get info from page 1 to page 2, you might as well use the put extra. If you only needed to go to one destination, use the singleton if it's going to a lot of different screens, whether you're going to change it or not. So it's really going to be the behavior that you're going to use for that, that variable. Okay. So now let's look at some other things that we can do with our screens. So let's do something with screen 2 here. So right now, if I go to screen 2, it looks like this. So what I want to do is I want to be able to put a whole bunch of numbers in here. All right. Now, how do we show some text on the screen? We use a text view, right? Now, up to this point, all the text views we've created beforehand. We created at the time, we go into our interface and we create a text view. Well, what if we don't know how many text views we're going to have until we get to that second screen? So for instance, our second screen is receiving an array with 10 elements in it right now. And what if I want to create a text view for each of those 10 elements that has the number in it? So the first text view will say 1, then 2, then 3, then 4. So I'm going to create 10 separate text views. And then I want to get them into my scene somehow. I want to get them into my screen. So I'm going to need some sort of container in here for receiving these things. Now, we've seen how we lay things out up to this point. So we have, if I go to my project here, and I go to my resources, layout, I go to screen 2. Right now, screen 2 has this linear layout that has this text view in it. All right, now what I'm going to do is I'm going to put another linear layout below that, so we have screen 2 will always be there, and then I want to have kind of a container for holding my text views. So inside of this, I'm going to go to layout, I'm going to create a vertical linear layout. I'm going to drag it onto my text view. Oh, sorry. I'm not dragging it on my text view. I'm dragging it below my text view. So it's inside of my original vertical linear layout. I have two elements. I have a text view followed by a vertical linear layout. Now I'm going to change the name of this. I'm going to actually give it a name for this linear layout because I want to have access to this guy programmatically. I need to use MVC here. So I'm going to call this guy the container. Let's call it the vertical linear layout, just to really spell out what this guy was. Okay, so he's going to be the vertical linear layout for this screen. Now I intend to throw text views in there, but I don't know how many text views are going to go in there yet, and I don't know what they're going to say yet. So I need to figure that out once screen 2 becomes alive. I'm going to go ahead and grab the array I received, and I'm going to have to create a new text view for each element of that array and fill it with the text associated with what's in that array, and then I need to add it to this guy. Make sense? So we'll go to screen 2. Now I need to give myself programmatic access to that linear layout. We could do it as a local variable here. It's not going to hurt anything. So I'm going to go ahead and take out these couple of print lines here. So we're still going to need our array. Then I'm going to go ahead and I'm going to say, now, a layout, the type of animal that a layout is something called a view group. So this is going to be a difference between iOS and Android. In iOS, we have these things called view controllers. And we've said that view controllers and activities are kind of the same animals. They do the same stuff. Okay? Now, a view controller controls a view, and that view can have other subviews in it. In Android, a view doesn't get subviews. Instead, a view group is a collection of views or other view groups. So if we go back here, we see that this is a view group. This view group holds a collection of views and other view groups. Make sense? So that's what a view group is in Android. In iOS, view group is handled within the view data structure. So views hold their own visual as well as other views, which can hold other views themselves. So it's a hierarchy of views, just design decisions they've made. So I'm going to grab this view group programmatically so that I can throw things into that view group. I can throw views into that view group. All right, so a view group is a collection of views and other view groups. That's what a view group is. So I'm going to go ahead and give myself programmatic access to that guy. That guy's name is the vertical linear layout. So go back to screen2.java, and I'm going to create a view group called the VLL, vertical linear layout. And this guy is going to be equal to this dot find view by ID r.id dot the vertical linear layout. Now this guy is going to come out as a generic view, which tells us that a view group is actually a view. It's a specialized version of a view. So I need to say I want the view group version of that. Convert him into a view group. This is called typecasting. So convert that guy who comes out as a generic thing, convert him into a view group and store him inside this variable. now I can put things into that variable. So I'm going to go ahead and I'm going to just, as a sample, I'm going to create a new text view. So instead of grabbing an existing text view from our interface, I'm going to create a brand new one. So I'm going to say text view TV is equal to a new text view. Okay, so now there's 4 different ways of creating a text view. The only one we care about is this first one. We have to create a text view in terms of the context in which it's going to exist. And it's going to exist in this activity. So we're going to pass in this to that guy. I intend to add it to this activity. Don't have to worry about that too much. Just the context that whenever something asks for a context, you pass it the activity, as far as you know right now. That's a 94% truth. When you get to more complex things, that changes a little bit because you might be creating something now that's going to live in a different context later on or something like that. That doesn't exist in our world yet. All right, so I built a brand new text view. Now this guy's blank. He has no text. So I'm going to go ahead and set his text. He also doesn't have like fancy fonts or anything. So, I would have access to, back to screen 2. If I click on this guy, which is a text view, that text view I just created comes with all of these properties. So I can come over here and look at the different things I can change to make it bigger font, different font, change the gravity. I can do all that stuff programmatically. All right, but right now let's keep it simple. The one we really care about is the text that's on the text view, right? So we'll come back to screen 2. And we're going to say tv.setText to LOL. So I create a brand new text view called LOL. Well, called TV that's set equal to LOL. Then I'm going to go ahead and I'm going to say the VLL.addView. And the view I'm going to add is TV. Now, the VLL is a view group that plays by some special rules, right? Because I made him a vertical linear layout. So as I throw things in there, they're going to get stacked on top of each other because they automatically lay out vertically because that's the kind of animal I created. Okay? So I'll run this. When I get to screen 2, behind the scenes, it's going to generate a brand new text view, throw the word LOL in it, then throw it on the screen inside of that bottom vertical thing. All right, and I created this guy out of nothing. There's page 2. There's my LOL. All right, now, if I want this guy to go ahead and fill out a whole bunch of text views for all of my individual numbers, so I'm passing in an array, right? So here's my array that I got. I want to create a new text view for each element of this array where the text in that text view is going to be the string version of the number in that array, because this is an integer array, right? So first of all, how do I spin through every element of that array? For loop. So I is equal to 0. How many elements are in that array? AR.length number of elements, increment I. So each time through that array, I want to do something. What do I want to do? I want to create a brand new text view. And then I want to set that text view's text to something. Now the thing I want to set it to is the string version of the number that lives at bucket I of AR. How do I get that? How do I get the string version of an int? Oh, what kind of animal is an int? Is it an object or a primitive type? Primitive type. What's a primitive type? What's the definition of a primitive type? Yep. Built into language, only capable of holding a value. That's the important part. So it can only hold a value, doesn't have functions like toString, right? Yeah. No, it's good. You got a whole bunch of right stuff today. You got an A for the day so far. I wouldn't ask the questions if I didn't expect wrong answers sometimes. All right, so primitive types aren't going to have functions. So we have to do something to this guy to get, I have an int, like the int 5. And I need this guy to become the string 5. How do I do that? Okay, so here I have something that looks like this. And so you want to typecast that. I ultimately want it to look like this. So how do you want to typecast it? So if I have something like int a is equal to 5, you're hoping that string a would boil down to that? No, won't do that. But this was a fun little game, right? So we looked for all these difficult solutions. Remember we talked about the power of the empty string? Take the empty string, concatenate on A, I'll get the string value of the contents of A, which is 5. Strings are really important in Java. They're very malleable, and an empty string is a good building block. Effectively, what did I do right here? I did what you tried to do here, right? You said, look, I want that dude to be a string, but typecasting him is not going to do it. But I mean, this effectively is typecasting him, right? It's like, here, I'm going to take this number, I'm going to shove it into the empty string. And because concatenation just works, it's built into the language, I'm going to get the string representation of that number. Make sense? Nice little trick that we can use all over the place. Empty strings are going to be a go-to move for a lot of stuff. So it's going to be pretty easy for me to get the numeric version of this. So I'll say tv.setText equal to the empty string concatenated with AR at bucket I. This creates a brand new text view. Now, if I were writing this maybe a little bit more efficiently, I would probably say text view TV up here. And then I would set TV here, use it, and then each time through I'm just giving it a brand new value. That way I'm not creating another variable every single time through. I'm just changing the value of an existing variable. Marginally more efficient. But we don't care about memory because we got a lot of it. All right. And then the last thing we'll do. Now, why can't I use TV right here? What's the explanation for why TV is underlined in red right there? Okay. Well, it is used inside the for loop. So it's telling me it's never heard of it here. I mean, I still want to add it to my vertical linear layout, don't I? But specifically, why can't I use TV? Didn't I define it here? Well, but it might not. I mean, when I get here, our array has 10 elements in it, doesn't it? Well, our array has an array.length number of elements. Okay, so I am setting a value to it in here, right? What kind of loop is a for loop? It's a pre-check loop. Pre-check loop. So how many times will the body of this loop execute? Potentially 0. So when we get to here, TV might not have a value. Does that make sense? Might not have a value. Now, we wouldn't want it out here anyways, because we really want to add TV every single time we get a TV. Now, if we're in here, do we know that TV has a value? We do. We know that TV has a value. Now, let me ask this question again. Now why is TV not allowed down here? Notice there's no underlined squiggly. It's in red now. Scope. Perfect answer. One word. Scope. TV lived and died in this scope right here. So when I get here, it's going to say, I haven't heard of this dude. Cannot resolve that symbol. Make sense? So some people might say that they want to define their text view in here so that it doesn't impact their scope outside of here. So that later on I could create, if I go ahead and move this guy in here, I could create another variable down here. TV like that. So doing it this way, even though it might be a little bit less efficient because I'm actually creating a new variable name each time through in that scope. That scope's going to die soon anyways, so maybe who cares? This guy, this solution, has what's called less coupling. Have I mentioned coupling in here? Okay, what's coupling? Okay, when something relies on something else in our program. It could be a function. Usually it's with objects. So when one object, we have two different files, and there's things in these files that kind of rely on each other, then, you know, it's like when you have new puppies. You don't want to separate them. Well, in this case, you can't separate them. If you sell somebody this file, you know, you give them this puppy, it doesn't work without this puppy. All right, so you gotta give them both of them. So we want to avoid coupling whenever possible, but it's not always possible to avoid it. Well, this would be an example where we have purposely made a decision to avoid coupling, because no longer are we bound to, well, no longer do we have to follow the rules that we can't create a variable named TV down here. Because even though we had one up here, it lived and died with that scope. So you could make a pretty decent argument either way for whether or not to define your text view inside the for loop or before the for loop. So at that point, it's just choose your poison, but know why you're choosing it. Okay? So we'll leave it like this for now, a little more compact. So we'll go through every element of our array. Could be 0 elements, we pointed out. Create a brand new text view in terms of this context. Set that guy's text to be the string representation of the current bucket we're looking at and add it to our view. So we're passing the array holding the numbers 1 through 10 to that guy. So what would we expect to see on the next screen? Text views for 1 through 10. So there's our text views for 1 through 10. Now if I go into main activity and I change this guy to 1,000. Now my array is going to be size 1,000. I'm going to fill it up with the numbers 1 to 1,000. Run this guy again. What's going to be in that second screen? 1 to 1,000, but it's going to be not quite as accessible as we'd want it to be. We can kind of see the start of 25, but there's a whole bunch of crap down here that we can't get to. So how does that usually work on phone apps? If I have a list of stuff, I need to get to stuff farther down the list. What do? We got to be able to scroll, right? So what we're going to do here is we're going to go into our Screen 2 design. And we have Is it in widget? Let's just go to all. It'll be easier to find in there. Well, it didn't used to. We used to have something called a scroll view. Here it is. Yeah, there we go. So we have something called a scroll view. So what I'm going to do is I'm going to put the scroll view right here. And he came with his own vertical linear layout. I'm going to dump that guy. And I'm going to throw our vertical linear layout in there. Go ahead and run this. Go to page 2, and now we can scroll. Pretty convenient. This would be actually an example where this is way easier on Android than it is on iOS. iOS has something called a scroll view. That's called a UI scroll view. And it works like this. But this, I mean, that took no time, right? It was 2 seconds to put that scroll view in there. Well, you're probably talking, if you've worked with it before, a minimum of maybe 5 minutes. For iOS, there's some programming involved for kind of setting the constraints and stuff like that. So this becomes easier. Okay, so now what we want to do, I'm going to go ahead and for now, I'm going to commit these changes. Oh, have I not already? I never imported it. Okay, so we're going to go ahead and import this into GitHub. This will be my initial commit. And I'll grab this guy. Go back over here. We're not going to forget the homework assignment this time. So we're going to go and I'll write the assignment in as I'm giving it. So this should be homework 13, hopefully. Yep, homework 13. And so I'll say, given that, that's our starting point for this guy. So we want to, on main activity, create an interface that reads in the number of elements that you want in your array. Then, upon a button click, create an array of the appropriate size and fill it with 1 to number of elements that you entered. Then pass that array to another screen. On screen 2, you should sort the array and display it in order inside a scroll view. Make sense? Fill an array of random size because you can get to choose what size. Pass it over here, sort your array, fill up a scroll view with your sorted information, your sorted data. Now, in order for that to make sense, this needs to be random numbers. So fill it with random numbers. Otherwise, sorting 1 through number of elements, well, there's no sense in sorting. All right, we've created random numbers before. All right, I will see everybody on Tuesday. Don't forget, today is I don't know, International Day, whatever, down at the International office, starting from noon until 2 p.m. They have African food today, free food. Go and check it out. I know the students will appreciate it.